Hi guys, today we're going to be talking about dividing radical expressions, and this is log page 14 in your logbook. The first thing that we're going to talk about is the quotient of radicals rule. And the quotient of radicals rule says that if I have a radical whose radicand is a fraction, then I can either divide first, then take the root, or I can take the root first and then divide. It doesn't matter which way I do that. I can either divide first and then take the root, like this side, where I'm dividing a by b first and then taking the root, or I can take the root first and then divide, like this side, where I'm taking the root of a and the root of b and then dividing those. So let's look at the example that's in front of us. We have the square root of 25 divided by 49. 25 49ths is a fraction, but 25 isn't evenly divisible by 49, and I can't really do anything with that without getting a decimal. So I want to choose to take these radicals first, take these roots first. I want to follow this second method. So I want to take the square root of 25, which is 5, and the square root of 49, which is 7, and then I want to ask myself, am I able to simplify 5/7? And no, I can't simplify that, and it doesn't divide evenly, so my answer is 5/7. Now, the second thing that could happen is I can have a radical like the square root of 36 divided by 4. Now, this time, what I want to do is divide first, because 36 is evenly divisible by 4. So I want to take 36 and divide it by 4 and get 9. 36 divided by 4 is equal to 9, and now I'll take the root. The square root of 9 is 3. So it doesn't matter which way I do this. I can take the root first and then divide, like I did in the first example, root first, then divide, if possible, or I can divide first and then take the root. And I'll get the same answer either way I go. Okay, if I took the square root of 36 divided by 4 and I did the square root of 36 and the square root of 4, the square root of 36 is 6, and the square root of 4 is 2, and 6 divided by 2 is 3. So I can divide first and then take the root, or I can take the root first and then divide. It does not make any difference which way I do that. I still get the same answer. So what you're going to need to do is look at every problem and decide what is the easiest thing for you to do. Now, sometimes we cannot do either of these two things, and so we have to have another way in which to simplify our problems. And that is called rationalizing the denominator. Now, when I have a problem that looks like the one that's before me now, the square root of 25 divided by 3, the first thing that I notice is they're not both perfect squares, so I don't want to just take the square root of 25 and the square root of 3. Now, the square root of 25 I could simplify, but the square root of 3 I cannot, because it's not a perfect square. I know the square root of 25 is 5 because, like the PowerPoint says right here, it's 5 times 5. And 2 5s under the radical come out as 1 5 on the outside of the radical. But the square root of 3 can't be simplified any further because 3 is prime. Well, this looks like those previous examples, but this is not the way we want to leave our answer. We're going to look at this as the wrong answer. Why? Because the denominator contains a radical. If there is a radical in the bottom, in the denominator, it is customary for us to remove it. We do not want to leave that radical. The denominator must not contain any radicals or else it's wrong. Notice we have wrong in quotation marks. Why do we have wrong in quotation marks? Well, because right now this issue matters. We want you to be sure that you understand. Right now we don't want you to leave a radical in the denominator. But in the long run, like when you get into calculus, it's not going to make any difference at all. So it's kind of like when you were in elementary school and improper fractions were wrong. Okay, your teacher wanted you to always change them to a mixed number. But now that you're in high school math, improper fractions are fine. Actually, we even preferred them. So this example, we're going to say, is not customary to leave this way. We do not want to leave answers with a radical in the denominator. So what we're going to do is what we call rationalizing the denominator. Okay, how do we rationalize the denominator? If there is a radical in the bottom, like this problem that we're looking at, we've got 5 divided by the square root of 3, then you must rationalize it. And the way that we rationalize it is we have to multiply the radical expression by 1. Because if we multiply it by 1, we haven't changed its value at all. Now what we have to do is find a convenient one, something that will help us. So we're going to write this 1 as the square root of 3 on the bottom, and whatever we do to the bottom we have to do to the top. Do you see that this is just another way to write 1? It's a big ugly number 1. And then the next question is, why did we pick the square root of 3? Because this little square root of 3 down here in the bottom, in order to get out from under the house, needs a partner, because you have to have 2 3's in order to get out from under the house. So when I multiply the square root of 3 times the square root of 3, I have 2 3's now under the house. So those 2 3's under the house will be able to come out from the house. In the top, I have 5 square roots of 3. 2 3's under the house get to come out, so in the bottom I just have a 3, and in the top I have 5 square roots of 3. All right, let's try one more of those so that you can see what we need to do. If I had 6 divided by the square root of 5, I need to get rid of this square root in the denominator. There's only one 5 down here. It needs a partner so that it can come out of the house. So I'm going to put another square root of 5 down here. But if I put one more square root of 5 in the bottom, I also have to put one in the top, because I have to be multiplying by something that equals 1. And the square root of 5 divided by itself is equal to 1. So this is 6 square roots of 5 divided by the square root of 5 times 5, or 25. That's 2 5's under the house, so it gets to come out. So 6 square roots of 5 divided by 5. Okay, let's try another. We're going to do this one together as well. Actually, no, we're not going to do this together. I'd like for you to pause this video right now, and I'd like for you to try this one on your own. Try A and B on your own, and then come back to the video and check your work. So try A and B, and then come back to the video and check your work. Okay, so now we're going to try this and make sure that you have understood what we need to do to rationalize a denominator. To rationalize a denominator, if I have a radical in the bottom, I need to get rid of that radical that's in the bottom. This is the square root of 3, and I only have one 3 in the bottom. So that 3 in the bottom needs a partner. Now this 7 is not under the radical, so it doesn't need anything down here to partner up with it. Only the things under the radical need a partner. Whatever I do to the bottom, I must do to the top, because I have to be multiplying by that big, ugly number 1. So in the numerator, I have 2 times the square root of 6 times the square root of 3, which is 2 times the square root of 18. And in the bottom, I have 7 times the square root of 9, And now we're going to simplify. I'm going to do the bottom first. The square root of 9 is the same thing as 3. 7 times 3 is 21. So I took the square root of 9, which is 3, and then I multiplied the 7 times the 3 to get the 21. Now 18. I can simplify 18. So I'm going to come over here and I'm going to do my factor tree. 18 is 2 times 9. Now I hope that you can see that 9 is a perfect square. So I don't have to go through and do the factor tree again. I could just leave it and say that this is 2 times the square root of 9 times 2. And the square root of 9 is equal to 3. So 2 times 3 times the square root of 2 over 21. Now, if you can't see that, then you need to go ahead and do your factor tree. 3 times 3 for 9. So right here what I have is 2 times 3 times 3 times 2. Those two 3's come out as 1 3. So that's 2. This 3 comes out. That's really my square root of 9. And the 2 stays under the radical, the square root of 2. 2 times 3 is 6 times the square root of 2 divided by 21. I can't simplify any of that, so I will just leave it as it is. Okay, now let's look at problem letter B. Okay, letter B looks like this. 5 divided by 4 square roots of x. All right, the problem is the square root of x in the bottom. The 4 is not a problem because it does not have a square root over it. So this x needs a partner so that it can get out of the house. Whatever I do to the bottom, I have to do the same thing to the top. So this is 5 times the square root of x divided by 4 times the square root of x times x. So that's 2x's under the radical. They get to come out. So this is going to be 5 times the square root of x divided by 4x. That's all that can be done to that problem. So we're done there. Okay, let's look at another example. On this problem, we have a square root of x cubed in the numerator. Square root of x cubed in the numerator, and we have the square root of 5xy in the denominator. The problem is this square root in the denominator. What do we need to pair up with this 5? Well, it needs another 5. What do we need to pair up with this x? Well, it needs another x. What do we need to pair up with this y? Well, it needs another y, because all three of those are under the radical, and they all need a partner in order to get out from under the radical. Now, whatever we do to the bottom, we have to do the same thing to the top, because we have to just find a big, ugly way to write 1. So this is just an ugly way to write 1. So now we're going to multiply. So I have 5, there's an understood 1 right here. So 5 times 1 is 5. X cubed times x is x to the 4th times y. Over, now the 5 has a partner, the x has a partner, and the y has a partner. So I can circle, 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 and in the numerator I have 5x to the 4th y over, the 5 comes out, the x comes out, and the y comes out. Now, what about the numerator? Can I simplify the numerator any at all? Well, I think certainly that I can, because I have 5 and 4 x's and 1 y. So what comes out of the top? Well, here's two x's that get to come out as 1, and here's two more x's that get to come out as 1. So what I have is, I don't know why I made that so big, this x on the outside, a second x on the outside, so that's x squared, and a 5y left on the inside. And then this is 5xy. Now look what I have. I'm going to scoot over just a little bit. 2x is on top with the square root of 5y, and 5 and 1x on the bottom. And if you remember from your Math 1 classes, an x on the top cancels with an x on the bottom, so that all I have left is x times the square root of 5y divided by 5y. Now this 5y and this square root of 5y cannot cancel because this one is underneath the radical and this one is not. So now I'm finished. Okay. Rationalizing a cube root is a lot like rationalizing a square root. So let's look at this. Rationalizing a cube root. I've got the cube root of x squared divided by the cube root of 5xy. Now, what I have to remember is that with a cube root, we have to have groups of 3. So if you look right here, I've rationalized twice instead of once. And the reason that I've done that is because I need 1 5 and 2 5s to go along with the one that's already there so that I have a group of 3. So I'm going to rationalize the first time by saying, well, here's 1 5 to go with this 5. Here's 1 x to go with this x. Here's 1 y to go with that y. But really, I can't just take 1. I need 3 of them. I need 2 more. So 1 plus 1 plus 1 more, x plus 1 more, a y and a y plus 1 more. So I have to get 3 5s, 3 x's, and 3 y's in the bottom. Whatever I do to the bottom, I have to do to the top so that I have that big, ugly number 1. And whatever I do to the bottom, I have to do to the top so that I have another big, ugly number 1. So now I'm multiplying by 1 twice. So what does this give me? Well, on the top, I've got the cube root of 5 times 5, which is 25, x squared, and you understand there's a 1 here. So 1 times 5 times 5. X squared times x is x to the 4th. And y times y is y squared. So there's my top. And on the bottom, I have the cube root of 5 times 5 times 5. So there's a group of 3 5s. X times x times x. So there's a group of 3 x's. And y times y times y. So there's a group of 3 y's. 1, 2, 3. So they all get to come out. And that's what our whole purpose is to get all of the ones on the bottom out from under. So now I have the cube root of 25, and then I'm going to say x to the 4th, y squared, over the 5 came out, the x came out, and the y came out. Now let's check and see if I can simplify anything else in the top. Well, 25 is 5 times 5. X to the 4th is x times x times x times x. And I left my cube off. And y squared is y times y. 2 5s, I need 3. Here's 3 x's. There's an x left over. And 2 y's. So these x's get to come out. So my final answer then is the x comes out. I've got 5 times 5, which is 25, times x, times y squared, all of that over 5xy. Then I see that these x's will cancel. So this x cancels with that x, and I end up simply with the cube root of 25xy squared divided by 5y. Okay, I want you to try some. Rationalize these denominators. Pause the video and see what you can do with these real quickly, and we'll go from there. All right, let's look at these. I hope you paused the video and tried these on your own, because if all you're doing is watching me do them, then you will struggle. So, the square root of 2/3. Well, neither of those are perfect squares, so I'm going to go ahead and just separate them. I'm going to take the roots first. And seeing that I have a radical in the bottom, I'm going to have to rationalize. So I need one more 3 on the bottom. So the square root of 2 times the square root of 3 is the square root of 6. And the square root of 3 times the square root of 3 gives me 2 3's underneath. So they get to come out. And that's the square root of 6 divided by 3. Okay, the second one, the square root of x cubed divided by the square root of 5xy. Notice that I have a 5 that needs a partner, an x that needs a partner, and a y that needs a partner. Whatever I do to the bottom, I must do the same to the top, because I need that big, ugly number 1 there. So this gives me the square root of 5x to the 4th, because x cubed times x is x to the 4th, times y, over 5xy, because 2 5's get to come out as 1, 2 x's come out as 1, 2 y's come out as 1. Now I'd like for you to be able to see that at this point we can say that there are 4 x's under here. I need 2, so that I have 5 times x times x times x times x times y. So this comes out as 2, these two come out, these come out as 1, and these come out as 1. And so what I have is x squared times the square root of 5y divided by 5xy. Now remember that x squared is x times x. So one of these x's will cancel with this one. And now what I have is x times the square root of 5y divided by 5y. Now these cannot cancel here because this one's under the radical and that one is not. Okay? All right, let's try the last two. The cube root of 2 divided by 3x. Well, that's the cube root of 2 divided by the cube root of 3x. Well, let's look at it this way. I need 2 3's here, so we're going to put them under the same radical. And I need 2 x's here, so that I get 3 3's and 3 x's. Whatever I do to the bottom, I must do the same thing to the top, so that I have that big, ugly number 1 right there. Here's my big, ugly way to write 1. And now I'm going to multiply. So 2 times 3 times 3. 2 times 3 is 6, times 3 is 18. So this is the cube root of 18, x squared. Now I'm going to multiply the bottom. Well, 3 3's come out as 1 3, 3 x's come out as 1 x. So now I have the cube root of 18 x squared divided by 3x. And I know that there are no pairs, no groups of 3 under here because I already had it factored over here. There's 1, 2, 2 3's, and 2 x's. So I know I can't take any cube roots out of there. Okay, let's look at the last one. 192, that's the cube root, right? So the cube root of 192 x to the 8th divided by 3x. Well, if you think about the fact that 192 is divisible by 3 because 1 plus 9 is 10 plus 2 is 12, and 3 goes into 12, so 3 goes into 192. 3 goes into 192 64 times. 192 divided by 3 is 64. And x to the 8th divided by x, one of these x's will cancel with one that's down here. So this is x to the 7th. And this is the cube root of x to the 7th. So I want to divide this one first because it makes my work easier. And then I can think about 64. And if I think about 64, I know that 64 is on that list of perfect cubes, and I know that it is 4 times 4 times 4. So the cube root of 64 is 4, and then I have the cube root of 7 x's. So if I have 7 x's, how many groups of 3 can I get out of those 7 x's? 1, 2, 3, 4, 5, 6, 7. Can you see them all? Not quite. Well, I can see that there are 2 groups of 3, and so what I end up with is 4x squared times the cube root of x, because this little guy is left underneath the radical. All right, that takes care of all of your rationalizing and dividing radicals. So now I want you to try your work and have a good afternoon.